Do you need to know two redox reactions of group 2? So redox reactions, what do group 2 atoms always want to, group 2 atoms want to gain or lose electrons? Want to lose electrons, fabulous. They've got those 2 outer electrons. They want to get rid of them to form metal ions with a 2+ charge. So let's have a look at the first one. Let's have a look. This one we've been doing since year 7, probably before. Magnesium plus oxygen, which I always write as O2, goes to magnesium oxide. Magnesium, of course, is a solid. Oxygen is a gas. Magnesium oxide is a solid. Got to balance it. Probably the easiest thing to do is to just put a couple of 2s there. And they always burn. So metal oxides are formed. These are white solids. Group 2 metals burn vigorously in oxygen. So do you remember the magnesium reaction where you like your magnesium? White flame. Okay, so let's do redox, because we said it's a redox reaction, so let's just prove it. Oxidation state of magnesium is an element. 0. Oxygen is an element, it's 0. Magnesium in magnesium oxide and oxygen in 2-. So let's just make sure, have I told you the truth? Magnesium therefore has gone from 0 to +2, so he has been oxidized.
Yeah.
And oxygen has gone from 0 to -2, so he has been reduced. So we do have a redox reaction. Which is good, that's a relief. The one with water is slightly more, so that's with oxygen. So we also can do group 2 with water. Shall we do, let's do calcium. So let's take calcium and react it with water. And we're going to form calcium hydroxide and hydrogen gas. So we form calcium hydroxide solution, because I've got lots of water there. I've got a bit of calcium in there. What type of chemical will calcium hydroxide be? Will it be an acid or an alkali, do you reckon? A metal hydroxide. Yeah, brilliant. So we're going to form, we form an alkaline solution of calcium hydroxide. It's not a very strong alkali. They're not very soluble, so sometimes we form an alkaline solution of calcium hydroxide, and sometimes a white precipitate because group 2 hydroxides Let's do our oxidation numbers again, just to make sure I'm not lying to you. So, calcium solid. 0. Hydrogen in water. Yep. Oxygen.
-2.
Brilliant. Calcium in calcium hydroxide.
+2.
Yep. Oxygen in hydroxide.
-3.
-2. Hydrogen is going to be +1, and hydrogen gas is going to be 0. So calcium has gone from 0 to +2, so it has been oxidised, whereas these hydrogens have gone from +1 to 0, so they have been reduced. Now notice, hydrogen has gone from +1 to 0 here, but he stayed as +1. Why is that? So I've got 2 oxidation states of hydrogen in the end as my product. Why is that not a disproportionation reaction?
Because it hasn't. Oh, because not one's reducing, one's oxidised.
Fabulous, yeah. It's because hydrogen, he hasn't changed, has he? He's +1, +1. So he hasn't actually changed. I haven't got hydrogen's gone up and down. Only hydrogen has actually gone down and stayed the same. He hasn't done that. So from what we've looked at today, think about ionisation energies and so on, how do we reckon reactivity is going to vary as we go down group 2?
They're going to become more reactive because they're going to find it easier to lose electrons.
Yeah. Down the group, they become more reactive. Now actually we can just say because the ionisation energies decrease. And we just said why the ionisation energies decrease. And we're summarising there. Outer electron further away from nucleus. Therefore, more shielded and less attracted to the nucleus. And easier to remove. That's fine. So, remember that's the opposite to the trend of group 7. Why is it opposite to group 7?
Because they're trying to gain an electron.
Fantastic, yeah. Group 7 are gaining, group 2 are losing. So that's why we see the opposite trend.